Good morning, dear students. Welcome back to physics class. Today, I would like to introduce a new topic which is uniform circular motion. Can you recollect the definition of uniform circular motion learned from 9th grade class? When an object follows a circular path at a constant speed, the motion is said to be uniform circular motion. In uniform circular motion, an object undergoes change in direction or speed, but it should be having a constant magnitude or speed. Thus, this body has produced acceleration. Do you know what are the conditions to produce acceleration in a moving body? There are three conditions. First one is acceleration is produced by change in magnitude of speed. Second one is acceleration is produced by change in direction of speed. And third one is acceleration can be produced by change in both magnitude and direction of speed. You should know velocity of a body which is executed to uniform circular motion at any point on its path should be along the tangent at that point in the direction of its motion. How can give the justification to this statement? Suppose a stone tied with a thread is whirled or rotated horizontally and allows it to execute uniform circular motion. If the thread is left, what would happen to the stone? The stone would be moving tangentially at that point on its path at the instant of time when it is left. This is the justification of this point. Suppose an object is moving with uniform speed v in a circle of radius r as shown in given figure. Since the velocity of the object is changing continuously in direction, the object undergoes acceleration. This acceleration is called normal acceleration. Now, let us see what should be the magnitude and the direction of normal acceleration. For this, we have to consider the position vectors r and r dash and the velocity vectors v and v dash of the object when it is at a point P and another point P dash at two different instant of times as shown in figure 1. You know that velocity at any point is along the tangent at that point in the direction of its motion. The figure 2 shows the average velocity vector delta v of the velocity vectors v and v dash of the same object. As the object executes circular motion, so the velocity vector v is perpendicular to the position vector r and velocity vector v dash is perpendicular to the position vector r dash, which are seen in given figure. Therefore, delta v is perpendicular to delta r. You should see that delta v is obtained by the triangle law of vector addition of the two velocity vectors v and v dash. You know that delta r is the displacement vector, which is also obtained by the same method, triangle law of vector addition of the position vectors r and r dash. What should be the direction of average acceleration? Since average acceleration delta A is equal to delta V by delta T, where delta V be the average velocity vector, which directs along delta V. Thus, it is perpendicular to delta R. as delta V is perpendicular to delta R. If you place delta V on the line that bisects the angle between R and R dash, that is delta theta, you can see that it is directed towards the center of the circle. Given figure shows delta V and delta A for small time interval. From this figure, it is clear that delta V and delta A are again directed towards the center of the circle. Given figure shows that the average acceleration delta A becomes the instantaneous value of acceleration A as the time interval delta t approaches to 0. It is still directed towards the center of the circular path. From this, you can understand that the acceleration of an object which is executed through uniform circular motion is always directed towards the center of its circular path. So, this acceleration is also called centripetal acceleration. Can you say about what should be the magnitude of this instantaneous acceleration? Its magnitude is given by this mathematical expression, which is equal to limit delta t tends to 0 mod of v2 minus v1 by t2 minus t1, which is equal to limit delta t tends to 0 mod of delta v by delta t. Let the angle between the position vectors r and r dash be delta theta. Since the velocity vectors v and v dash are always perpendicular to the position vectors r and r dash, then the angle between them is also delta theta. This can be understood by comparing the two figures which are given below. So, the triangle CPP dash formed by the position vectors R, R dash and delta R, and the triangle GHI formed by the velocity vectors V, V dash and delta V are same. Therefore, the ratio of the base length to side length of one of the triangles is equal to that of the other triangle, that is mod of delta V by V is equal to mod of delta R by R. Then mod of delta V is equal to V into mod of delta R divided by R. You should not forget to use the operation mod whenever it needs to find the magnitude of the vector. Then the magnitude of instantaneous acceleration can be written as A is equal to limit delta t tends to 0 mod of delta V by delta t, which is equal to limit delta t tends to 0 V mod of delta R by R delta t. So, A is equal to V by R limit delta t tends to 0 mod of delta R by delta t, which is the expression 1. If delta t is small, delta theta is also small, and then the arc PP dash can be approximately taken to be mod of delta R. Then delta R is approximately equal to delta V delta t, since displacement is equal to the product of velocity and time. So, delta R by delta t is approximately equal to delta V, where delta V be the average velocity. Then limit delta t tends to 0 mod of delta r by delta t is equal to v. So, v is equal to limit delta t tends to 0 mod of delta r by delta t, which is the expression 2. By using the expressions 1 and 2, we get the centripetal acceleration AC is equal to v by r into v, which is equal to v square by r. So, AC is equal to v square by r, which is the expression 3. Why is normal acceleration of uniformly circulated body called centripetal acceleration? What is its magnitude? As normal acceleration is always directed towards the center of the circular path through where the body is moving, that is why this acceleration is called centripetal acceleration. The magnitude of centripetal acceleration of an object moving with speed v in a circle of radius r is equal to v square by r. As the object moves from the position P to the position P dash in the time interval delta t, that is t dash minus t, the line CP turns through an angle delta theta as shown in figure. So, delta theta is called angular distance. We define the angular speed omega as the time rate of change of angular displacement. So, omega can be mathematically written as omega is equal to delta theta by delta t. Let the distance traveled by the object during the time delta t be delta s, which is pp dash as shown in given figure. Then the magnitude of delta s will be equal to length of the arc pp dash, which is clear from the diagram given below. Then v is equal to delta s by delta t. Since delta s is equal to r delta theta, so v is equal to r delta theta by delta t, which is equal to r omega. Since omega is equal to delta theta by delta t, then v is equal to r omega, which is the expression 4. Another question, how can we express the centripetal acceleration AC in terms of the angular speed? We know that the centripetal acceleration AC is equal to v square by r. Since v is equal to r omega, then AC is equal to r omega whole square divided by r, which is equal to omega square r. So, AC is equal to omega square r. This is the relation between the centripetal acceleration AC and the angular speed omega. This expression is 5. Let us see what are the time period and frequency of this motion. You know that time taken by an object to make one revolution is called its time period, and the number of revolutions made by this object in 1 second is called its frequency. Time period is represented by capital letter T and the frequency is represented by the Greek letter mu. What should be the relationship between the time period and frequency? It is the time period T is the reciprocal of the frequency mu. So, mu is equal to 1 by T. You know that during this time, the distance moved by the object S is equal to 2 pi r, as speed v is equal to distance by time, which is equal to 2 pi r divided by t is equal to 2 pi r mu. since 1 by t is equal to mu. In terms of frequency mu, we have the angular speed omega is equal to v by r. Since v is equal to 2 pi r mu, then omega is equal to 2 pi r mu whole divided by r, which is equal to 2 pi mu. Now, you are going to see the relationship between the centripetal acceleration and the frequency mu. The centripetal acceleration AC is equal to omega square r, which is equal to 2 pi mu all square into r, since omega is equal to 2 pi mu, which is equal to 4 pi square mu square r. Then AC is equal to 4 pi square mu square r, which is the expression 6. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.